You are welcome to the GMAETS41 basic class channel. This is an online school on its own. Yes, because from this channel you learn step by step things that will guide you in your studies at school. And as a matter of fact, we have a scheme of work that guides us at GMAETS41, which we apply to our scholars in basic level of learning, because we understand what they need, and we also understand from GMAETS41 that our basic level of learning is very important, because as you are moving on to higher level, as to whether you will do well, if you will do well in higher level depends on how your basic level is established or built. So once again, I am welcoming you to this wonderful online class. And I want to assure you that you can do this. With GMAETS41, together, you can become best in your studies at school. In our class today, we shall be looking at simple equation, part 1. Simple equation, part 1. And you see on the board, in this part 1, we will focus and learn collection of like terms. The type of equation, the type of simple equation that involves collecting like terms. So you have this on the board. I'll just give you 1 minute to 2 minutes. You can copy this quickly or screenshot. I will advise, if you screenshot, it will be better for you because it will be fast. Maybe I'm sorry for that network interruption a moment ago, but I think the network is back stronger once again. Okay, so believing that you have screenshot what is on the board, and please, at the end of this class, a copy of this particular online class will be made available, so you can still come back where you will have time to pause the video and then write some things, okay? Because right now, this is a live class. Just like you are with your teacher in the class and the teacher is teaching you. Is that okay? So you can't pause it. You cannot pause the class. But please, you can come back later to be able to watch and then maybe copy the note or stop the video somewhere where you have questions to ask. You are welcome, Ebere Ufikaro. It's good to see you in the class today. This is going to be a wonderful class. I'll be a bit fast to explain what is on the board, okay? A simple equation is a mathematical statement. A mathematical statement that has two expressions which are equal. A mathematical statement that has two expressions which are what? Equal. You can see the definition on the board. A simple equation is a mathematical statement that two expressions are equal. So if I give you this, this highlighter, this is called the highlighter, and I give you this marker. If I tell you that they are equal, that becomes an equation. That becomes what? An equation. Call it simple equation. So anytime you have two expressions and you say that the expressions are equal, that is simply what we call simple equation. Or you can just say an equation. Take notes. So you have known what an equation is. Now, we said that an equation tells us that two expressions are equal. The two expressions that are equal, how do we know that they are equal? They are separated into left-hand side and right-hand side. And what separates them into left-hand side and right-hand side is called equality sign. It's called what? Equality sign. So you see this on the board. For you to know that something is an equation, you must have equal to. You must have equal to somewhere in that equation. And that equal to will separate the two mathematics statements or the two expressions. The equal to will separate them into left-hand side and right-hand side. You can see that. The two expressions are separated into left-hand side, which we are using LHS, and right-hand side, which we use RHS. So if you see LHS in mathematics, you know it is left-hand side. Yes, generally that's what we use. If you see RHS, you know it is right-hand side. So don't forget, imagine that I give you something like this. X equal to 2. This is an equation. It is a simple equation. How did I know it is a simple equation? Because you have equal to there. You have equal to. The equality sign separates these mathematical statements. You know, here you have X. It's a mathematical statement. On the right, you have 2. It is a mathematical statement. Yes. So the equal to separates it into two sides, the left-hand side and the right-hand side. Does that make sense? Now, I have on the board example of an equation, example of simple equation. X plus 5 equal to 6 is an equation, is a simple equation. X plus 5 equal to 6. How did I know that this is an equation? Remember, whether you call it simple equation or you call it equation, they are the same thing. This is a simple equation because I can see equal to somewhere there. And where is the equal to? Look at it. Equality sign. It is there. For that reason, X plus 5 equal to 6 is a simple equation. It's an equation. Now, like I said, the equation separates the mathematical statement, separates the expression into left and right-hand side. Now, watch the board. How do you identify the left-hand side and the right-hand side of an equation? How do you identify it? The first thing you have to do, take notes. The first thing you have to do is to locate the equal to sign. And this is our equal to. From here, this first part, the beginning of the equal to the left-hand side, that is what we call left-hand side, LHS. Anything you see there is on the left-hand side of the equation. That is from the beginning side of the equality sign. Then the end part of the equality sign, which is from here, going this way, is called the right-hand side. RHS, right-hand side. So what do we have on the left-hand side of this equation? What is the expression there? What is the mathematical statement there? X and plus 5. X and 5 plus 5, they are on the left-hand side. Then on the right-hand side, we have plus 6. This 6 standing like this is plus 6. That is why there is no minus here. This is plus 6. That's 6 alone there. I'll give you another example of simple equation. If I give you 2a minus 3 That's another example. Equal to, let's say 7. Okay, let me use A here. A plus 10. A plus 10. Good. 2A minus 3 equal to A plus 10. This is also an equation. It is a simple equation. Again, I ask, how do you know that this is an example of simple equation? How do you know that it is an equation? And the answer is simple. If you look at this, it has equal to. Equality sign is there. So simply, I get to know that this is an equation because of this equality sign. Now, we say that a simple equation is a mathematical statement that two expressions are equal. What are the two expressions here? This is one of them, and this is the second expression. These are mathematical statements. 2a minus 3 is a mathematical statement. It's a mathematical expression. A plus 10 is a mathematical statement. Is a mathematical expression. This A can represent anything. A can be maybe sweet. If A is sweet, I can now say 2 sweets. Like if I give you 2 sweets, and here you have 1 sweet. So somebody is telling you, okay, 2 sweets. You now have minus 3 equal to 1 sweet plus 10. I am not telling you that A here means sweet. No. What I am saying is you can assume it to be anything. Because in mathematics, whenever you see all these alphabet letters, they represent something in real life. We may not tell you what they represent, but yes, they represent something. As you are moving, you will learn more. All right. I need a moment so that I can put up light. My gen wants to go off. All right, so please manage up with me on this. Trying to ensure that we have light that we can use in running the class. Okay, so I think this is better. All right, I am back. And I hope you can hear me from that end. So, this is an equation here we have on the board. And I've told you why this is an equation. 2a minus 3 equal to a plus 10. Now, this is the left-hand side of the equation. From here this way is the left-hand side of the equation. And then from this part this way is the right-hand side of the equation. So if I ask you, what do we have on the left-hand side of the equation? On the left-hand side of the equation, we have 2a minus 3. And on the right-hand side of the equation, we have a plus 10. Okay, this is important. Now, take note, this 3 that you have here is minus 3. Minus 3. Why is this minus 3? In front of the minus, you can see, in front of the 3, you can see minus there. You can see minus. If you are working with mathematical numbers, right? With numbers, the sign in front of the number, you must respect it. You must respect it. So this is not just 3. Rather, it is minus 3. Then this 10 here is plus 10. It is important that you take note of this, because when you are solving a simple equation, sometimes, depending on what you are asked to do and what you have in that simple equation, you can do what we call collection of like terms, like we have here, which we are going to treat. If I am talking of this 3, I must respect that it is minus 3. Let us assume I want to move this minus 3 or this 3 to the right-hand side. You don't throw the minus away. You have to respect that that 3 has minus. This minus belongs to this 3. The sign of a number always appears before that number, just before that number. And that sign goes with that number. Please take note of that. Take note of that. Okay, now you have known what simple equation is. You have known the left-hand side and the right-hand side of a simple equation. You have also learned that an equation is identified by equal to. You must see that equal to there. At this point, I want us to talk about like terms. I want us to talk about like terms. Very important. It is after we learn about like terms, we can now solve questions. Please take notes. You don't just start solving questions anyhow in mathematics. This is one of the reasons why some scholars find it difficult to handle some mathematics problems. Before you know they are looking for questions, you must understand the foundation of what you are about to do, so that when your coach or teacher is solving these questions, you will understand what you are being taught. Now, let us talk about like terms. What are like terms? This is the note on the board. Like terms are terms that are the same. Terms that are what? The same. They are terms that share the same quality. They are terms that share the same what? Quality. And what do we mean by saying that they are the same or they share the same quality? The example I have on the board here will explain that better. So let us look at what we have on the board. E.g., numbers are like terms. Pure numbers, pure numbers. If I give you numbers and there is no alphabet attached to it, there is no alphabet multiplying that number, I call that type of number pure number. I'll give you an example. Look at this 5. Is there any alphabet multiplying it here? No. Please don't confuse the fact that you have X on that left-hand side. Between this X and this 5, you have plus. So this X is not attached to this 5. It's not. If the sign were to be minus, If it is minus, the x again is not attached to 5. It's not. So this 5 here is pure number. This 6 is also pure number because there is no alphabet attached to them. Pure numbers, I said, they are what? Like terms. Take note. So if I give you 20 and 0, they are like terms. If I give you minus 8 and 17, they are like terms because they are pure numbers. No alphabet is attached to them. We call them like terms. Now, let us talk about like terms when we have alphabets. How can you identify alphabets that are like terms? Now, listen to this. The alphabet or letters must be the same. I repeat, the alphabet or letters, for them to be like terms, they must be what? The same. For example, look at this. X and 5x, they are like terms. X and 5x are like terms. How do I know that? If you look at this other x here, it has 5 attached to it. This is 5 times x, which we pronounce 5x. Between this 5 and x, we have times 5x. So this 5x you are seeing here is actually pure alphabet. The 5 you are seeing there is not really a number. Like, no. This thing means you have x, 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 x. 5 of them, and they are being added. X plus x plus x plus x plus x. How many of the x do I have here? 5 of them. And you have plus, plus, plus between them. If you add all of the x together, you will get 5x. 5 times x. So that 5 you are seeing here is telling you, multiplying this x, attached to this x, is telling you the number of x that you have there, which are added. So this term you are seeing here, 5x, is a pure alphabet. It's an alphabet, x, 5 of them. And this one is 1x, 1x, only one of it. So this is simply alphabet x, letter x, and this also letter x. The only thing is that here you have 1 of the x, and here you have what? 5 of the x. It is just like I have this marker and this marker, black markers. They are like terms. If I ask you how many markers do you have here, what will be your answer? Your answer will be 2 markers. 2 markers. Is that okay? So, you want to take note of that. 5x and x, they are like terms. For alphabets to be like terms, they must be the same. Now, look at this one. 2a on the left-hand side of the equation. Then go to the right-hand side of the equation. You have a. 2a and this a. This a means 1a. 2a, 1a. They are like terms. They are like terms. Why? Both of them are a's. A. The only thing is that this one is 2 of a and this one is 1 of a. It is just like maybe you have 2 sweets or 2 oranges, and I have 1 orange, and I have 1 orange. Orange, they are the same. You have 2 of the oranges, I have 1 of the orange. That is the meaning of this. 2a and 1a, or simply a. So they are like terms because they are the same alphabet. These 2 you are seeing here, it's only telling you how many a's you have. The 2 there is not a pure number. It's not like this one. Alphabet is attached to it. So what you have here is actually a and a with plus between them being added. A plus a. We give you 2 of a, 2 a's. And like I said, these 2a and this a, they are like terms. They are like terms. Then look at this number, minus 3 plus 10. They are like terms. Minus 3 plus 10. They are like terms. Why should you know about like terms? Why? Why are we talking about like terms? This is because if you are solving any problem in mathematics that is an equation, the like terms must come together. They must come together. You don't leave like terms to be scattered in an equation. It's never done. So you collect them together. Now I have a question for you. If you do not know like terms, if you don't know like terms, how can you bring them together? Will it be possible? So you see that if someone does not know like terms, if you see a question like this, you might be confused on what to do. So let us summarize this idea of like terms. Simply put, although you have the note, the grammar written on the board, but this is what you want to always remember. Pure numbers are like terms. That is, numbers without alphabet attached to them, without alphabet multiplying them. Numbers, pure alone. For example, 5 and 6. You can see 5. That's it, 6. They are like terms. Look at this one. Minus 3 plus 10. They are like terms. Now look at this one. 2 minus 7. Pure numbers. There is no alphabet attached to them. They are like terms. Take note that the numbers must not be equal. It's not compulsory that they must be equal. All we know is that they are numbers, whether they are equal or not. They are pure numbers, and so they are like terms. Then when you come to alphabets, how do you know alphabets that are like terms? The alphabet must be the same. And it does not matter how many of the alphabets you have. As long as they are the same, they are like terms. For example, you have X here, and you have 5x, 5 of X, that is 5x. Since both of them are X, they are like terms. Look at this, 2A and A, 1A, they are like terms. The alphabet must be the same. Now, let me ask you this question. Are these like terms, 2X and 2Y? Are they like terms? Are they like terms? The answer is no. They are not like terms. Why are they not like terms? Look at the alphabet here. X. This one is Y. X and Y, are they the same alphabet? No. So they are not like terms. So even if you have 2 here and you have 2 here, the 2 you have here does not make them like terms. No. The alphabet are different. Therefore, they are not like terms. This thing is just like somebody having, let's say, 2 sweets, and another person has 2 pencils. Sweet and pencil, are they the same thing? No. So if you have 2 sweets and your friend has 2 pencils, they are different. They are different things. So they are not like terms. Always remember, for alphabets to be like terms, the alphabet must be the same. It does not matter how many the alphabets are. I can have something like 5T and 1000T. Because both of them have TT, they are like terms. Even if this is 5T and the other is 1000T. As long as the alphabets are the same, they are like terms. Thank you very much, Ebere, for commenting. No, because the alphabets are not the same. That's very true. So these ones are not like terms. They are not. Okay, I have told you why you should understand what like terms are. I've given you one reason. Another reason is because, which comes from the first reason I gave to you, that like terms, you bring them together. You bring them together. Another reason is because when like terms come together, you can add them, you can subtract them. This one is not on the board, so you can find somewhere and write it down. Like terms can be added or subtracted. Write it in your notebook. Anytime you are coming for our class, you should come with your notebook and writing materials. Because sometimes I may say something and I want you to write it. It may not be on the board. Like terms can be added or subtracted. When you bring them together, bringing them together is to add them or subtract them. It is only like terms that you can do that to. If you have something that is not like terms, you can't add them, you can't subtract them. I'll give you a quick example here. If I, like this place, I have x plus, if I say x plus 5x, you can add them. X plus 5x, 1x plus 5x will give you a total of 6x. You can add them because they are the same thing. They are like terms. You can add. You can also subtract them. I'll give you another example. Suppose it is 5x minus x. This thing means 5x minus 1x. You can solve this thing and get 5x minus 1x. 5 minus 1 is 4. So this is 4x. You can solve this thing like this. So like terms can be added or subtracted. But what of unlike terms? Unlike terms. You know, terms that are not the same, that do not share the same quality. Unlike terms. They do not share the same quality. They are not the same. Maybe if I give you something like 2x plus 2y, can you add this? Can you subtract them? You cannot. And the reason is simple. These are not like terms. They are not like terms. Krish, you're asking, sir, you are from which country? Okay, I am from Nigeria. Okay, I'm a Nigerian. Unlike terms, 2x plus 2y, you cannot add them. Please, my dear friends, don't go and write anything like this that you are solving and you say 2x plus 2y is equal to 4xy. It is wrong. You can't add them. If I have minus here, 2x minus 2y, and you say it is equal to 0, because you have 2x, you have 2y minus equal to 0, you can't do that. Because these are unlike terms. They are not like terms. So you can't add them and you can't subtract them. But for like terms, you can add, you can subtract. I hope I am communicating. You see the way we learn on this channel. We have no choice. Because I believe that anybody that comes to this channel, there is something you should pick. Whether you are in basic level, this channel is dedicated to our basic scholar from basic 4, 5, 6, 7, 8, and 9. But those in advanced level, in senior high school, senior secondary school, you also need some things we are learning here. My dear basic scholars, yes, I am referring to them because this channel is dedicated to them. There are some people in senior class that have problems with this. Because when they were like you, they refused to learn some of these things. Or maybe they were not coached very well. All these little things, they matter. And you see this topic, simple equation, as you move on to your higher class, even at this your present level, this present class you are, anything that has to do with solving something that has equal to, you need simple equation knowledge to guide you. For example, this term, many people in different schools, in basic level, will be learning things about shape, geometry, you know, area of a triangle, area of a rectangle, Pythagoras theorem, you know, Pythagoras theorem for right angle triangle. You'll be learning something like statistics, data collection, how to calculate mean, You need simple equation. That is why I decided to start off our online class, live class, with some of these topics. In our last class, I taught you board maths. Because you need all these things, all these topics. If you have not learned these topics, board maths, simple equation, rules of divisibility, how to do multiplication and division, then these other topics you are going to meet, you might be finding them difficult. So please, our basic scholars, take these topics seriously. Those in advanced level that decided to connect to this class, please, if you have a younger one, use this channel to help them. They need it. And if you yourself need it, fine. If you yourself need it, fine. I am from India watching your simple equation. Thank you very much, Vlogs Diaries. You are welcome to join us from India. I hope you friends are good over there in India. All right, dear friends, we have finished all these things, and I have told you everything about simple equation and like terms. I hope you have copied this on the board or screenshot it, because I am going to wipe the board now. Then I will give you a note, something to note before we will now solve something about collection of like terms. So I'm wiping this. We are done with this. I will leave this part for the moment. Please note, if you are solving simple equation, there are certain things you want to have in mind. Note, I told you something that in simple equation, sometimes one term may cross equality sign. What do we mean by all these 10? If you have something like, you remember we had 2a minus 3. That 2a, before the 3 you have minus. So the 2a is one term. The minus 3 is another term, okay? So those things we write, they are called terms in mathematics. So note, number 1, if plus crosses equality sign, if plus, this is the symbol, crosses equality sign, this is equality sign. It changes to minus. You want to remember this. It changes to minus. Then number 2, if minus crosses equality sign. If minus crosses, this is a symbol of minus, crosses equality sign. Equality sign. It changes equality sign. And I've told you that equality sign, oh no, what am I writing? Equality sign, okay. And this is equal to sign, equality sign. It changes to, tell me what it will change to. It changes to plus. That's good. It changes to plus. So you want to be guided by this, because we'll be dealing with this thing. We're going to be using it when we solve questions. Anytime you are solving equation involving collection of like terms, this is always used. We always meet it. Number 3, when solving an equation that has, plus or minus, collection of like terms is used. Or let me put it this way, it will make more sense to you. When plus when plus or minus is between the unknown and another term and another term, you collect like term, comma. You should collect like term. You should collect like terms. Collect like terms. So you want to know when to collect like terms. You collect like terms when there is plus or minus between what you are looking for and another thing that is not its like term. Looking for between it and another term, there is plus or minus. For between it and another term, there is plus or minus. That is when you do collect like terms. That's when you do that. So you want to remember this point 3. You want to remember it. We shall pick one question and just solve. In our next class, we'll still treat this. We'll solve questions in that our next class. I've taken my time to introduce simple equation very well for you. So you need this class. In our next class, I'll be solving questions directly that involves collecting like terms. This is just part 1 of it, where I actually introduce the meaning of simple equation and what we mean by like terms. That is what like terms are. Let us just look at this question. Let's look at this question, and that will be all for today. So this is the question. Find the value of y in 5 plus 3y minus 2 equal to 15 plus 2y. Since this is the only question we are going to solve, I decided to give you something like this. I could have started with simple questions like maybe x plus 2 equal to 10. Find x. But we have not started solving question. Take notes. Solving of question under collection of like term will start from our next class in mathematics, which is next week. We have a timetable. Is it next week? No, I don't think so. I think this week we'll still have maths. This week we'll still have maths. The times are today. Okay, so solution. You want to solve a mathematics problem, you write solution because you are solving a problem. The question given to us, bring it down. 5 plus 3y minus 2 equal to 15 plus 2y. First, I will ask myself, is this an equation? And without wasting time, the answer is yes, it is an equation. How did I know that this is an equation? You can see equal to there. You can see equal to there. Let me check the network. Gosh. Network is disturbing. Oh my God. This has started. I experienced this challenge, this problem yesterday. I guess it is network that is causing it. I experienced this problem. I'm trying to find out why it is happening. Please, we'll just round off this. I would still think of what is happening. I encountered this problem yesterday. Let me just solve this on the board. I can't just stop it. Please, from here, quickly, you will collect like terms. Collect like terms. Now, I always like bringing alphabets to the left. This is serious. This is serious. Why now, when I'm rounding off the class? Why now? Please manage up this. I'm so sorry. I really don't know why this is happening. Manage up this. Let me just round off. It's network, I guess. So we are going to collect like terms quickly without wasting time. Let me write it. Collect like terms. Collect like terms. Now, I like moving the alphabet to the left and then the numbers, the pure numbers to the right. That's what I like doing, but it is not a law. It's not a rule, but it is best. Because usually if you are solving, the alphabet will now be on the left equal to something on the right. So if you look at this, we have 3y alphabet on the left. On the right-hand side, you have plus 2y. It's also an alphabet. So move this 2y to meet 3y. This 2y that is going to meet 3y. This 3y here is plus 3y. That 3y is already on the left-hand side. So you write 3y on the left-hand side and move 2y from the right to the left. Then, look at this number 5 and look at this one minus 2. They are pure numbers. They are like terms. Move them to the right to meet this 15 because this 15 is also a pure number. This will give us, on the left-hand side, this is positive 3 plus 3. So just write 3y plus 3y. Write that 3y. If you want to write plus 3y, the choice is yours. Okay, let me just leave it as plus 3y. But plus 3y is the same as 3y. Then this plus 2y is coming to the left-hand side. For plus 2y to leave the right-hand side and come to the left-hand side, it will cross this equality sign. And I told you if plus crosses equality sign, it will change to minus. So plus 2y coming to the left to become minus 2y. I have moved this 2y to meet 3y as like term. Now, fix equal to. Fix equal to because you want to move all the numbers to the right now. On the right-hand side, we have this number 15. It's already on the right-hand side, so you write it first, 15. Then, this minus 2, move it to the right. If minus 2 is moving, it's crossing this equality sign. So it will change to plus 2. Then this 5 standing here is plus 5 because there is no minus before it. This is serious. The network is just making this so difficult for me. But like I said, just manage. Till the thing is still showing. Let's round off, okay? So let's have this. Plus 3y is the same as 3y. If I give you plus 3y, it's still the same as writing 3y. You don't need to put that plus. It's not compulsory. Since this is the first term that you see in the equation here. So plus 3y is the same as 3y. This will now be 3y minus 2y. It's just like you have 3 oranges minus 2 oranges. If you have 3 oranges and you remove 2 oranges, you'll be left with 1 orange. So 3y minus 2y will leave us with 1y. And if you have 1y, you don't write the 1. You don't write the 1. Just write y. So this becomes y equal to, you now move on to the right-hand side. Once again, 3y minus 2y. 3 minus 2 will give you 1. Then you pick one of the y. But like I said, it's simple. You have 3 oranges. Minus means you are removing. You remove 2 oranges from it. You'll be left with 1 orange. And so 3y minus 2y is 1y. You don't need to write the 1. There is just y. Then come here, 15 plus 2 will give you 17. You see, I taught you about maths. You do addition first before subtraction. 15 plus 2 will give you 17. 17 minus 5 will give you 12. So this is equal to 12. and this is your answer. Therefore, y is equal to 12. You have solved this. This network. So, I hope you enjoyed this class and you learned something. I'm sorry that towards the end, the network started disturbing, that this thing is just blinking. I don't know why. It's hanging, trying to cut, and then the network is just going and coming. I just hope that you understood this. But like I said, we have not started solving questions. We have not. I just decided to do this for you to appreciate what you have learned today from this class. Thank you for connecting, and I hope to see you in our next class. Like I said, there is a timetable that guides us on this channel. Are you following, right? So let me check and see. Today is Tuesday, so we had maths. So tomorrow being Wednesday, we have English from 7 o'clock to 7:30. Then on Saturday, we have maths again from 7:30 to 8 o'clock. So our next maths class, where I will start solving directly, that class, once I come, I introduce it, we start solving questions on simple equation involving collection of like terms. Okay, that's what we're going to do. I'll be seeing you on English language, seeing you for English language rather tomorrow. And make sure you are available. We are going to treat now. We are going to be treating now as part of speech. Good night and enjoy your sleep.